In the 1910s, aviation didn't fail because of bad pilots. It failed because nobody truly knew how flight worked. There were no regulations, no certification standards, no safety margins. Every single flight was an experiment. And sometimes the experiment failed. Hi, it's Captain Cart, and this is Aviation by Decades, a series where we explore how aviation accidents didn't just end flights, but reshaped the way we fly today. In this episode, we're going back to the 1910s, the decade where powered flight was born through trial, error, and loss. To understand aviation accidents in the 1910s, we first need to understand one thing. Aviation had no rules, because aviation had no knowledge. Aircraft in this era were built from wood, fabric, and wire. There were no stress calculations, no fatigue data, and no real understanding of aerodynamics. There was no proper testing, no load factor analysis, no certification process. Pilots weren't just pilots, they were test pilots by default. On September 17, 1908, during a demonstration flight at Fort Myer, Virginia, a modified Wright brothers aircraft took off with 2 people on board. The pilot was Orville Wright. The passenger was U.S. Army Lieutenant Thomas E. Selfridge. Shortly after takeoff, a propeller failed. The aircraft lost control and crashed. Orville Wright survived with serious injuries. Thomas Selfridge did not. This was the first fatal accident involving a powered aircraft. Selfridge wasn't just a passenger, he was the most knowledgeable aviation officer in the U.S. Army. He had worked closely with Alexander Graham Bell, was part of the Aerial Experiment Association, and was the first Army officer to solo a powered aircraft. His death wasn't just tragic, it was a strategic loss for early aviation. Because of this accident, the U.S. War Department delayed acceptance of the Wright brothers aircraft, and military confidence in aviation dropped sharply. For the first time, aviation faced a hard truth. Courage was not enough. Flight needed engineering. At this point in history, aviation was split into 2 completely different philosophies. Lighter-than-air aircraft relied on buoyancy. Balloons, airships, and dirigibles floated using gases like hydrogen or helium. This is static lift. They rise because they are lighter than the air they displace. They don't fight gravity, they avoid it. Heavier-than-air aircraft were fundamentally different. They were heavier than the air around them, and they had to generate lift dynamically, or they fell. Airplanes and gliders relied on airflow over wings or rotors. No forward speed, no lift. 2 principles made heavier-than-air flight possible. Bernoulli, pressure differences over the wing. Newton, downward deflection of air creating a reaction force. By the end of the 1910s, many believed airships were the future of commercial aviation. They offered long range, high payload, and smooth flight. But they carried one fatal weakness. Hydrogen. Hydrogen provides excellent lift, but it is highly flammable. In 1919, the Wingfoot Air Express crashed, killing crew members and people on the ground. This accident exposed a brutal reality. Lighter-than-air aircraft were operationally impressive, but catastrophically unforgiving when things went wrong. Fire was not just a risk, it was an inevitability. Now let's look at one of the earliest commercial airplane disasters, the Capronico 48, a large triplane originally designed as a military bomber and later converted for civilian passenger transport. On a return flight from Venice to Milan, witnesses near Verona observed violent wing oscillations. Seconds later, the wings collapsed. The aircraft disintegrated in midair. This was flutter. Flutter is a high-frequency, self-exciting aeroelastic instability. It occurs when aerodynamic forces, structural flexibility, and mass distribution interact in resonance. Instead of dissipating energy, the vibration feeds itself. The oscillations grow exponentially. Structural failure follows within seconds. Every structure has a natural frequency. When external forces match that frequency, resonance occurs. Bridges oscillate in wind. Glass shatters at specific sound frequencies. Aircraft wings can tear themselves apart. Flutter is resonance in flight. Flutter is structural. There is no warning. There is no recovery. The Caproni didn't lose lift. It lost its structure. By the end of the 1910s, aviation had learned 3 painful lessons. Structure matters. Materials matter. Engineering must come before ambition. Aviation could no longer rely on bravery alone. Science had to catch up with imagination. The 1910s were aviation's childhood. Chaotic, dangerous, experimental. In the 1920s, aviation begins to grow up. Air routes, navigation, regulations, and the first real safety systems emerge. That's next on Aviation by Decades, How Accidents Shaped Flight. If you haven't seen them yet, you can check out my shorts for individual crash breakdowns. Thanks for watching. I'm Captain Cart, and this is how aviation learned to fly.